Here we go. 8-1B. I doubt it. Like, we got to do this. Yeah. We might get it back next week. All right, combined variations. Okay, so yesterday, did we have this class yesterday? Yeah. Yesterday, or in the notes or in the video, whenever you saw it, you learned about two types of variations, direct and inverse, okay? Today we're going to still do direct and inverse variations, but then we're going to do some combined variations at the end. So let's get started. Letter A. First thing they want us to do is they want us to be able to identify whether something is a direct variation or an inverse variation. And sometimes they're going to give you a table of values. Sometimes they give you an equation. Sometimes they give you a situation like we did yesterday. Those were all the word problems. Today we're going to do more equations and stuff. So if you're going to identify, you need to know what they look like. Direct variation is y equals kx. Okay? Ooh, I'm glad you asked. Yes. K is called the constant. I know it starts with a C. Constant of variation. Okay? It's not a variable. It's actually going to be a number. It's a constant. Numbers are constant. It's going to be like 10 or 1/2 or -3 or whatever. Okay? Inverse variation looks like this. Y equals k divided by x. So when you, and k is the same thing, constant variation. When you are directly related, you're related straight across to something. When you're inversely related, you divide. Okay? So what we're going to do is we're going to have a problem where all we have to do is identify, we're going to identify whether it's inverse or direct. And if it's inverse or direct, then we are going to find out what k is, because k is going to be a number. It's going to be a constant. Okay? So I've got 3 examples here. So a situation can either be direct, inverse, or neither. Neither happens sometimes too. So let's start with this one. We have x and we have y. I'm going to give you a table of numbers that are going to go together. So when x is 0.5, y is 1.5. When x is 2, y is 6. And when x is 6, y is 18. Some of you guys might be pretty good at recognizing this right away.
Yeah, you multiply by 3,000.
Oh, close. I mean, not close, but...
-30.
No, you're on the right track. Okay. How do you get from x to y?
You multiply by 3.
You multiply by 3. Exactly. So let's look at this. Let me show you this way. All the x's are all going up. 0.5, 2, 6. All of the y's are also going up. So they're going in the same direction. If you're going in the same direction, then it's probably going to be direct. We're not sure yet. Now, if it's direct, that means all of their proportions have to be the same. So k equals, if I go to up here to direct, what does k equal? If I solve for k equals what?
3.
No, just
Constant
right here.
Variation. Oh.
K is the constant variation, yep. So if I go to the direct equation, y equals kx, and I solve for k, what does k equal?
2.
Y over x.
Oh, yeah.
Okay, so if you solve for k, right here. So let's do that. Let's find out what y over x is. And you already did this. You saw it right away. Bless you. Y over x is 1.5 over 0.5, which is 3. Y over x is 6 over 2, also 3. 18 over 6, 3. Did it change at all? No. So this is going to be direct variation without the question mark, and k equals 3.
Oh, that's...
I know, good. That's pretty good, huh? Okay, so then our equation for this would be, the equation would be y equals 3x. And you knew that already, even without really going through all the steps. If you plug in a number for x, you multiply it times 3, you get y. right, let's try another one.
Now in the streets, they call me K3.
They do not.
Yep.
All right, here we go.
Right now, you know what I'm saying?
X and Y. What streets are you on? All right, point 2 is 12.
Streets on the way to heaven because I'm on Jesus.
Oh, good. Point 6 is 4. And 1.2 is 2. Now, this one's a little tougher. A lot of decimals going on, really hard here. Okay. No, we're going to. We can't do all the easy stuff in life, unfortunately. All right, take a look at the X values. As we go down the row, or down the column of X values, we go 0.2, 0.6, 1.2. These are going up. And the Y's are what? Oh, 12 to 4 to 2. They're decreasing, they're going down. So this is not a direct variation. Okay, this is going to possibly be an inverse.
What else could it be?
Neither.
Okay.
Yeah.
I'm gonna erase this.
Oh, there could be a neither too.
Yeah, I'll show you neither in just a minute.
Why?
So if it's inverse, that means that y equals k time or over x. Y equals k over x for an inverse. So let's find out what k is. If it's inverse, k is equal to what?
Can't you just like divide?
Yeah, multiply both sides by x. K would be x times y. Remember yesterday their products were all equal to each other when it was inverse? Same thing here. So let's find out all of their products. What's 0.2 times 12? Do you know that? It's 2.4. You can do that on your calculator if you need to. What is 0.6 times 4? Guess what it is? 2.4. What's 1.2 times 2? Guess what? 2.4. Okay. So this is an inverse variation. K is equal to 2.4. So our equation would be y equals 2.4 divided by x. There you go. And you can test it if you want to. You can plug some x values in and see if they actually turn out to be those y's. All right, so we did one of each. Now let me show you what a neither looks like. Neither you're going to like because all you do is write neither and you don't have to find k, you don't have to find the equation, you just move on. So this is what a neither would look like. You have an x and y. And let's suppose that this is 1 and 2. And this is 2 and 4. And this is 3 and 9. Okay. So this looks to me like a direct variation. These are increasing and those are increasing. And so I'm thinking direct. Well, I know with direct, all of their proportions have to be equal. Okay? So I start off by finding all of the y over x's for all of these. So 2 divided by 1 is 2. Okay? 4 divided by 2 is 2. But 9 divided by 3 is what? 3. Okay, yeah.
That's not good.
It's not. So this is no bueno. This one is neither. This has a pattern to it. Does anyone recognize the pattern? Squaring. Yeah, it's the squaring function.
I don't like that.
This is just y equals x squared. Y equals x squared is not a direct variation. See our direct variation right here? What is y equals kx? Starts with an L.
Lenny.
Linear. It's linear.
Lenny.
Lenny. No more Lennies. Oh, we're out of logs, by the way. Yes. Some of you are going to be glad. Some of you are sad. You will not do logs again until the final exam.
I'm definitely.
Yeah, or never again for seniors. Some seniors. Okay, here we go. Now we're going to do some variations. Variations. Hey. All right. Number 2. This is what they're going to do. They're going to say, suppose that x and y vary inversely. Number 2. The last one was number 1. They had A, B, C. Yeah. All right, suppose that x and y vary inversely. So they have to tell you which way it varies, directly or inversely. And then they'll say that x equals 4 when y equals 12. This is what we're going to do. We're going to write an equation for the situation. And then part B, we are going to find out what, where is it? What is y, find y when x equals 7. Okay? So you're going to write an equation, a general equation, and then you're going to be able to plug numbers in to see what you get if they change. Okay. So here we go. No. Well, yeah. At the end there is. Yep, substitution. Okay, suppose x and y vary inversely. Now, if x and y vary inversely, then we're going to have y equals something over x. Y equals something over x, right? That's what inverse is. Y equals k over x. But what is k? Well, in inverse variation, k is the products. Do you remember that from yesterday? It's the products. No. So that would be to divide them. K is going to equal 4 times 12. 48. Okay, so this equation is y equals 48 over x. That's our general equation. That's it for part A. Part B is now, let's... You're not ready? Okay. See, inverse variation is y equals k over x. K is equal to x times y. It's their products. So we plug in 48. Now, let's go ahead and find out what y is. This is part B. When x equals 7. It's not going to be pretty, is it? No. Y is about 6.857.
It's almost pretty.
Almost. You could leave it as 48 over 7 if you wanted it in fraction form. That's it, yeah.
It is pretty because everyone's pretty.
I always do squigglies because it's not exactly equal to that. It actually goes on forever, but I don't really mark off for that. Okay, let's do a direct now. It says, suppose x and y now vary directly. Suppose x and y vary directly. Okay? And what they'll do is they'll give you one situation. They'll say x is 10 when y is 3. And we're going to have to come up with a specific equation. And then they're going to say, what is y when x is 50? Okay? So write that down. Catch up to me. Suppose x and y vary directly. X equals 10 when y is 3. Find an equation, and then we'll plug that in. So here we go. Direct variation looks like this. Y equals k times x. And I need to find out what that k is. It's a constant. K is always going to be, solve for k right here. What is k equal to?
The constant.
It's the constant variation. And for direct, it's proportions, just like you did yesterday on that worksheet. All of those direct variations were all proportions, right? Butter is to sugar as butter is to sugar. All the proportions were equal. So let's find out a proportion for this. Our proportion for this one is 3. Make sure it's always y over x. Okay? 3 over 10. So my equation is y equals 3/10 x. That's the answer to part A. Part B is now they'll give me a number, and all I gotta do is plug it into my equation. So once you have that equation set, you're ready. So let's go ahead and plug 50 in. Y equals 3/10 times 50. Do you know how to do that in your head?
No.
I'll show you. Watch. 10 divides into 50 how many times? 5. And 3 times 5 is 15. Isn't that nice?
Yeah.
You don't even need to pull out your calculator and deal with all that.
But no, me, I'm gonna have a brain fart and everything.
Because you don't trust your brain?
No.
Same. I do that too. All right, letter C, last part.
Touch their brain. That's like physically impossible.
That's gross. All right. Now we're going to combine it all together. We're going to combine them. So, in order to combine all of these variations, I need to show you, you're going to have like a third variable come in. So here we go. It says here that Z varies jointly. Oops. jointly with x and y. Okay, z varies jointly with x and y. When you write that as an equation, you would write z equals. Z varies jointly. X and y for jointly, that means that they are joined together. Okay? Z equals, you still need that constant because there could be a number out front. And then x and y are joined together, multiplied. Okay? So that's what jointly is. If it says z varies jointly with x and y and inversely with w. See, these get a little complicated. But as long as you know some of these words, writing the equation is going to be pretty easy, okay? So for this one, you have two things going on here. You have jointly, and you also have inversely. So when you write this one, you're going to go z varies, so z equals. Jointly with x and y, that's going to be exactly what we wrote down here, so they're all joined together. K times x and y, and where do you think w is going to go?
Next to the y.
No.
What?
It's inversely.
Oh.
Under. Remember, inversely is divided by. Divided by. Well, you do now. I wish I knew that. Okay. Let's do some examples of this. Number 4. I've got 2 more. Can we make it?
Yeah.
Okay. Number 4. It says here that z varies jointly with x and y. Z varies jointly with x and y. And then what they do is they'll have to give you what all of those 3 things are. They'll tell you that z is, where is it? Z is 28, x is 7, and y is 2. So this is what we're going to do. We're going to write an equation for this, okay? So you're going to start by writing a generic equation. Then you have to find out what k is, and then you got to put k into your generic equation, okay? So let's do this. It varies jointly, and we just found out what that means. That means that z equals k times x times y. They're all joined together. But this k right here needs to be replaced with its constant. It's a constant. So let's find out what k is by taking z, x, and y and plugging them all in.
Oh, this is algebra.
Yeah, not too bad, huh? It looks really complicated at first, but it's not bad. 28 goes in for z, k, and then x times y is what? 14. Solve for k. So let's divide by 14, so k is 2.
K2.
So go back to here and plug it in. Our equation is z equals 2xy. It's so funny because people will solve for that and they'll get k, but then they forget to plug it back in. So that is my equation. I don't want k in my final equation. I want what k is. K is a constant. In this case, it's 2. And then part B will ask you to do something like this. What's z when x is 6 and y is 4? And once you have your equation, you just plug it in, right? And you can use your calculator if you want to. That's fine. So z would be 2 times 6 times 4, which is 48. Didn't need your calculator. 48. Pretty good, huh? All right, let's do one more. We have time. Number 5. All right, let's do, ooh, this one's tough. Are you ready for the hardest one of all?
Wait, okay.
Yes. Z varies, so no sleeping anymore. Z varies directly with x and inversely with the square of y. Yes. With the square of y. I'm going to tell you what that means. Not the square root, but the square of y. Okay, this one's tricky. So we're going to also be given that x is 35 when y is 7 and z is 50. We have to be told the 3 pieces of information so that we can find k. All right, so the first thing you're going to do is you're going to write down a generic equation with k in it. That's step number 1. And then you'll plug all those in, find out what k is. All right, here we go. Oh, we're going to run out of time.
No, we're not.
Z varies directly with x, so straight across with x. Directly means I'm going directly there, okay? Inversely with the square of y. Ooh, there it is, y squared. Now, plug everybody in. How did we run out of time? I know, right? But what happened? We didn't do anything more than go over homework. I walked around. Yep, see? Takes too long. I know. Talked about Fergie. Yeah, maybe that was it. All right. Anyways. You get k equals 70. Let me finish the video really quick. Oh, you did the homework? Perfect. Beautiful. Where were you?
Doctor's appointment.
Oh, okay. Z equals 70 x over y squared. There you go.